Welcome to the Chanmat Gadgets. Today we'll learn relation on a set. In a previous video we have seen relation between two sets. Now we'll learn what is relation defined on a set. Okay. So if R is a relation on any set A, then R is a subset of Cartesian product of A cross A. Okay. Then this relation R is said to be relation on a set. There are three types of relation. First one is reflexive, second one is symmetric, and third one is transitive. Okay. So relation R is said to be reflexive if for all elements of set A is related to itself. Okay, that means A is related to A. Okay, that is this element A comma A belongs to R. Okay, now see an example. The relation is equal to is a reflexive relation. Okay, if I take set of natural number n, then we know that every natural number is equal to itself. Okay, so that means on a set of natural number this equality is a reflexive relation. Okay, now let's see second relation, that is symmetric relation. A relation R is said to be symmetric if I take two elements from set A, then if A is related to B, then B is also related to A. Okay, that is if A comma B belongs to R, then B comma A must also belongs to R. Okay, now see an example. If I take set of straight line, then perpendicularity is a symmetric relation. Okay, if I have set of straight line, that means if two lines are perpendicular, that is A is perpendicular to B, then we can see B is also perpendicular to A. Okay, so perpendicularity is a symmetric relation. Now another example, if I ask you, is brotherhood a symmetric relation? So one can say yes, but it is not a symmetric relation. Why so? Because if I say A is brother of B, then is B a brother of A? This is not always true. Suppose if A is boy and B is girl, then A is brother of B, but B is not a brother of A, B is a sister of A. Okay, so brotherhood is not always a symmetric relation. Okay, now third one is transitive relation. A relation R is transitive if any three elements from set A, if A is related to B and B is related to C, then A is related to C. Okay, if this happens, then relation R is said to be a transitive relation. That is, if A comma B and B comma C belongs to R, then A comma C must also belongs to R. Okay, now see an example. Divisor is an example of transitive relation. Okay, if I take set of natural numbers, then if A divides B and B divides C, then A also divides C. Okay, so divisor is a transitive relation. Now another example, if I ask you, if I have set of straight lines in two dimensional plane, okay, and relation is perpendicularity. So if I say A is perpendicular to B and B is perpendicular to C, then is A is perpendicular to C? No. Why so? Let's see. A is perpendicular to B. Okay, this is line A and this is line B. Okay, so here we can see A is perpendicular to B and I am saying B is perpendicular to C. So this line is C. We can see here B is perpendicular to C, but here A is not perpendicular to C. A is parallel to C. Okay, so perpendicularity is not a transitive relation. Okay, I hope everything is clear to you. Now let's see one more definition which is very important: equivalence relation. If any relation R is reflexive, symmetric, and transitive, then that relation R is said to be an equivalence relation. This concept of equivalence relation is very important, because if there exists a equivalence relation on a set A, then using the relation we can do the partition of that set. Okay, we'll learn more about the partition of set in future upcoming videos. Now let's see a question based on the concept of equivalence relation. Let S is a set containing elements 1, 2, 3, 4 and 5, and we have relation R. The relation R is this contains element 1 is related to 3, 2 is related to 4, 3 is related to 5, 1 is related to 1, 2 is related to 2, 4 is related to 2 and 3 is related to 1. Then is R an equivalence relation? So let us first see, is it reflexive relation? After that we'll see, is it symmetric? Then we'll see if it is transitive or not. Okay, so first one is reflexive relation. So for reflexive relation, so every element of set A must relate to itself. Okay, so 1 is related to 1, we can see here. 2 is related to 2, but 3 is not related to 3. Okay, so relation R is not reflexive. Okay, so relation R is not reflexive, that means it is also not an equivalence relation. We do not need to check further. Okay, now this video ends here, and I have a quick announcement to make. Those who are preparing for exams like CSR Net, GATE and other MSc entrance examination can buy a real analysis handwritten notes for a very reasonable price for only ₹80. So if you are interested, you can contact us through this WhatsApp number. Thank you. Thanks for watching.